Hello dear students. In my last video, we had discussed about the classification of lubricant, and in this video, we will discuss about the mechanism of lubrication. Mechanism is classified into three types: fluid film, hydrodynamic, thick film lubrication. Second is boundary lubrication or thin film lubrication, and third one is extreme pressure lubrication. In hydrodynamic lubrication, we introduce a thick film of liquid lubricant between two metal surfaces, and in boundary film lubrication we introduce a thin layer of lubricant, and in extreme pressure lubrication we add additives with mineral oil or any other liquid lubricant. First we will discuss about the fluid film lubrication. In this type of mechanism, the moving sliding surfaces are separate from each other by a thick film of liquid fluid at least 1000 angstrom thick. The liquid fills cover the irregularities of sliding moving surfaces, thus prevents direct contact between material surface and wear is minimized. Coefficient of friction of unlubricated surfaces 0.5 to 1.5, which reduces to 0.001 to zero point zero 0.03 for lubricated surface. This small friction is only due to internal resistance between particles of lubricated moving over each other. In such system, friction depends on the thickness, viscosity of lubricant and relative viscosities and area of moving sliding surfaces. Therefore, the lubricant chosen should have minimum viscosity under working condition. In this type of lubrication, we use liquid lubricants like vegetable oil, animal oil, and mineral oil, etc. This is the diagram of thick film lubrication. We can see that a thick film of lubricant is introduced between the two metal surfaces. Now we will discuss about the boundary film lubrication. It is done when a continuous film lubricant cannot persist and direct metal to metal contact is possible due to certain reason. This happens when shaft starts moving from rest, or speed is very low and load is high, or the viscosity of oil is too low. Under such conditions, the clear space between moving sliding surfaces is lubricated with oil lubricant. A thin layer is absorbed on both metallic surfaces, which avoid direct metal to metal contact. The load is carried by the layer of adsorbed lubricant on both the metal surfaces. In boundary lubrication, the distance between moving or sliding surfaces is very small, of the order of high of the surface asperities. In this type of lubrication, we use semi-solid like grease and solid lubricants like graphite, molybdenum disulfide, etc. This is the diagram of thin film lubrication. As we can see, a thin layer of lubricant is applied between the two metal surfaces. If we want to use vegetable or animal oil in this lubrication, we have to add some additives to improve the quality. The third type of lubrication is extreme pressure lubrication. When the moving or sliding surfaces are under very high pressure, speed, high temperature is attained, and under such conditions, liquid lubricants fails to stick and may decompose or even vaporize. To meet this extreme pressure condition, special additives are added to mineral oil called extreme pressure additives. Example of such additives are chlorinated ester, sulfurized oil, and triglyceryl phosphate. The process of mechanism is when chlorinated ester, sulfurized oil, and triglyceryl phosphate type of additives are added to the mineral oil, they form a film of metal chloride, metal sulfide, and metal phosphide. These metallic layers are very stable and have high melting point. Thus, these layers, due to high melting point, act as a lubricant between two surfaces under high pressure and high load. This is the diagram of extreme pressure lubrication. We again revise. This lubrication is for very high pressure, temperature, speed in between two sliding surfaces. Extreme pressure additives are used along with the lubricants. Chemicals used are compounds of chloride, sulfide, and phosphide, and resulting they form metal chloride, metal sulfide, and metal phosphides, which are the solid surfaces. High melting point of metal compounds are good lubricant. For this purpose, we can use graphite for drawing wire made up of mild steel. So we can again revise. Then all the lubricants are used according to their conditions, according to machines, and according to their application. We can modify lubricants in our laboratory to fulfill our conditions and according to application. So this was the mechanism of lubricant. Thank you so much. Have a good day.